In this lesson, we will be adding polynomials. Let's go ahead and look at our first example. We have a squared plus 2a minus 4, and we're going to add that with negative 4a squared plus 3a minus 6. So these are polynomials. That's more the general name, and this specifically is a trinomial because it has 3 terms that we're going to add to another trinomial that has 3 terms. When adding polynomials, you're pretty much going to be looking just for the like terms. So let's write out our steps so we can do this work. So we're going to line up like terms. And recall, when we are lining up like terms, we're going to be looking for the same variable with the same exponent. So let's take the first polynomial, a squared plus 2a minus 4. We're going to add that with the next polynomial. So we're going to line up the like terms. Our a squared term will line up with the a squared term. The a term will line up with the a term, and then the constant will line up with the constant. So this one worked out nicely that the first and second polynomial had all of the same like terms. So now we combine the like terms. When you are combining like terms, always keep in mind x plus x gives us 2x. When you're combining apples with apples, they don't turn into oranges. Apples plus apples are still going to be apples. What I mean is this does not equal x squared. Don't make them a different term. X's plus x's are still x terms, not x squares. We do make it x squares when we're multiplying. X times x is when it is x squared. But of course in this lesson we are adding, not multiplying. Let's do that now. We have a squared, we're adding with negative 4a squared. In front of the a squared there is an understood 1 if you need to show that in order to combine. 1 plus negative 4 is negative 3a squared. 2 plus 3 is 5, and of course a, because when we combine those like terms, our answer is that like term. It's still an a term. And then negative 4 plus negative 6 gives us negative 10. Take a look now at example number 2. Here we have negative 3x minus y. We're going to add that with 2x plus 4y plus 3. So this time we're going to take a binomial and add it with a trinomial. Binomial meaning we have 2 terms, and trinomial with 3. So because it is a binomial and a trinomial, we have to be careful with our like terms and make sure we get them all lined up. I'm going to start still with the first one, negative 3x minus y, and add that with, when I line up my terms on the next one, just being careful because I know I have more terms, I'm going to have something that won't line up. So our 2x term lines up with our x term, 4y lining up with our y term, and it's here in our constant that we don't have anything to line up with. And that's okay. If you imagine, you could tack on a plus 0, so you'd be combining it with 0. So if that really would help you, then do it. Let's combine. Negative 3x plus 2, negative 3x plus 2x gives us negative 1x. If you just want to write negative x, that is acceptable. The 1 is not required. Negative 1, that's what this is when there's not a coefficient. So negative 1 plus 4 gives us 3y And then of course we'll bring down that constant because we're really adding it with 0. It would stay a 3. Example number 3. We have w to the third power plus 2w minus 6, and we're going to add that with 3w cubed plus 3. Feel free to pause the video at this time and try this one on your own. So I'm going to write my first polynomial, w to the third plus 2w minus 6. We're going to line up our like terms with that binomial. 3w cubed. Notice the plus 3 is not a w term, so we do not want to line it up with the 2w. That plus 3 is a constant. We want to tack it on here at the end. W to the third power plus 3w to the third power gives us 4w to the third power, not to the 6th or the 9th or anything else. When I combine, maybe I have watermelons. Watermelon plus 3 more watermelons gives me 4 watermelons. Okay, they don't turn into anything else. When I bring down my next term, I have 2w since I didn't have anything else to combine it with. And negative 6 plus 3 gives us negative 3. Now for number 4. Here we have 3p to the second. We're going to subtract 1 and add that with negative 3p squared minus 2p minus 4. Let's line up our like terms. So taking our first one, 3p squared, we notice the trinomial that we're adding actually has a p term. So here a p squared, let's give ourselves some space before we write our minus 1. That way we'll have a spot for that p term. So we're adding our negative 3p squared minus 2p minus 4. Sometimes looking ahead, especially when you have a binomial and a trinomial, helps you set up the work with your like terms. Feel free to switch the order. Addition is commutative, meaning you could switch the order and it's still going to come out the same. So feel free to start with the trinomial and then put the binomial underneath. 3p squared plus negative 3p squared, those actually cancel. So those we no longer have. Our p term will just bring down because there's nothing to combine it with. And negative 1 plus negative 4 gives us negative 5. Let's take a look at one final example. Now I'm going to set it over here in this next column since I have the space. So number 5. Let's say that we have a rectangle. So you can actually draw a picture of a rectangle or just write out the word. For this rectangle, we're given that the length of one side of the rectangle is 2x plus 7. So again, if you're drawing a picture, just label the length 2x plus 7. And we're given that the width is going to be 6x minus 4. So again, on your picture, if you're drawing that, label the 6x minus 4 for the width. So I want us to find the perimeter. So recall that perimeter just means the sum of all sides. So in the case of a rectangle, there actually is a formula you could use, 2L plus 2W. And if you know that formula, feel free to work it out that way. But I tend to like to stick with the sum of all sides. That way if I'm working with any other figure, like a triangle or a hexagon, or anything else that has different sides than just a rectangle, I know to just add up all the sides. Because that 2L, 2W only works for rectangles and squares because they're really rectangles as well. So let's add up all the sides. for our perimeter, well, length and width, we definitely have that on each length and width side. Think about the other two sides where I have the length again, 2x plus 7, and width again, 6x minus 4. So we're actually going to need 2 of the lengths and 2 of the widths. So I tend to like to set up blank plus blank plus blank plus blank. And that way I know if I'm dealing with a rectangle, I need 4 sides to fill in those blanks. 2 of them will be my length and 2 of them will be my width. If I'm just dealing with a triangle, I would only have 3 blanks because I only have 3 sides. And now I'm able to fill in based on my length and width. So 2x plus 7, I'm going to have another 2x plus 7, and then 6x minus 4, and then another 6x minus 4. So let's line up these like terms. 2x plus 7, 2x plus 7, 6x minus 4, and 6x minus 4, and add those together. Of course, if you're able to combine your like terms with it written horizontally, feel free to use that. Writing it vertical is not necessary. 2 plus 2 is 4, plus 6 is 10, plus 6 more gives us 16x. 7 plus 7 is 14. Take away 4 is 10. And take away 4 more, we have 6. So the perimeter of that rectangle would be 16x plus 6.